Hello and welcome everyone to this week's Hour of Code. Today we're going to be talking about Git, the version control system, and sort of the basics that you really need to know. So Git is the de facto standard version control system in use today, and it's just incredibly useful for even for solo projects. Even if you don't work with other people, you still want to know how Git works because it lets you experiment and then either reset or throw or save or keep for temporarily all your different code versions. And but its real benefit is, of course, when you start working with other developers, then it becomes even more important because it provides a really nice and lovely way of keeping track of changes and who made them and when they were made, and keeping like branches, which is what we call like temporary diversions from the main path, so to speak. But we'll go through all of that. So what's on the screen right now is, one, I have my lovely little terminal window here, and I also have a brief overview of what we will be talking about today. So there's a bunch of Git commands, which sort of represent most of the normal workflow, I would say. And then hopefully we'll also get time to talk about these things. So there's another Git command here, which is not particularly it's not like an automated part of the real workflow, but it's very useful to know. We'll talk about using Git with and without the so-called third-party Git providers, which is GitHub, GitLab, and Bitbucket. I'll show you how to make a repo in GitHub, and then I'll also, hopefully, if we have time, I'll show you the normal pull request workflow, which is sort of like how you normally work with GitHub and having other people provide code for you, or basically if there are multiple people coding on one project, you'll probably use pull requests. So let's get started, right? So Git is first and foremost a terminal. It's a terminal thing. It has you use it directly from here, so I can type Git, and it will tell me, hey, you didn't use a command, but this is Git. So it's not unlike other console commands. It has a bunch of sub commands, they call it. Some of them which we can see here in the background. In fact, I wonder if we should maybe just do this, where I sort of make this really big, and then we can make this a lot smaller. There we go, that should be nice. So the very first thing you probably want to do is you want to make some code, because Git is kind of useless directly on its own. So we're going to go through my workflow for when I start a new project. So I always, I'm a C# coder, so I will use Visual Studio. So I create a new project. Doesn't really matter. I'm going to make a new console application here. We're going to call it Hour of Code .git stuff. We're not going to write any important code here today, so it's just a sample. But here we go. This is perfect, right? We have created some files. So let's actually go look at those files. So we will go to code, and we will go to Hour of Code Git stuff. We have our solution file. We have our Git stuff file, which has some stuff in it. So we're saying, okay, we wanna make a project out of this so we can keep track of what's happening. Well, the trick then is to go in here, of course. Let's open up this again so we can see what we're supposed to do. Actually, let's minimize this then as well. And then we'll need to, whoops, wrong window. We'll need to go into that folder. So Git is kind of folder based. So we want to be inside the folder that is our, if we do ls here, we'll see, yeah, this is the right folder. So here, if we type Git Init here, it will initialize Git inside this folder. We could do that here, but given that this is actually a, you know what? We could do that, but if we had multiple projects, then that would be the right thing to do. But since this is only one project right now, for C#, it's kind of traditional that you don't initialize your repo out here. In fact, you do it inside here, where you have your CS proj file. If it's only one thing, we don't need to have the solution outside. So we'll do it in here. So we'll type Git Init. And then it says initialized empty Git repository here. And it also told us that, hey, using master as the name of the initial branch, the default branch is subject to change to configure the initial branch name, la la la. Yeah, so this is like some people don't like the word master for their main branch. Like GitHub, for example, by default creates things with the word main now, and also trunk is pretty common. But master is, I'd say, still the sort of default, but they are saying it is subject to change. So, we'll see what Git, the official Git policy will be later on. But for now, it's master. So now, if we type Git Status, it will tell us that you are on branch master, there are no commits, and you have untracked files. This simply means that so on branch master, because like when we initialized it, it created the default branch, right, which is master. There is no other branches at the moment. We have no commits. That's like the biggest issue here. It basically means that the Git repository contains no known states. 99% of Git is creating commits and referring to commits in different ways. For example, when I say a branch by itself is literally just a very shallow pointer pointing to a particular commit. And a commit can have a parent, well, actually not can have, they have a parent usually, right? So commits in turn are connected. And branches are just short pointers towards them. So let's start adding things, right? So we're going to add some files. So one way of doing this is to just do like git add. If you just type git add like this, it's going to do nothing. So nothing specified, nothing added. And then it says, hey, did you actually mean to do git.add dot, which will add any modified file? And I could do that. However, if we notice what the untracked files are, we'll see that there's two files we want to put in. We want to have our CS project file and our program.cs file. We definitely want those in the repo. But obj, that's when you build a .NET project, you'll create a /obj and a /bin folder. You should not check those in. Oh, I should quit Steam, by the way. You should not check those into your repository. That's just considered bad practice because those files are not source; they are binary, and so you can either not add them, but there is a better way. There is an even better way, and I'm going to show you that better way. Right? We're gonna open up Visual Studio Code in this folder by doing code dot. Jesus, this is new. Yes, I trust the authors. That's me. We can then here create a file. We'll create a new file and we'll call it .git ignore. Now, inside a .git ignore file, anything you type in here is like pattern based, will be folders that it will try to ignore. So we can do obj slash. So there we go. We can do bin slash. We can do .vs slash. These are folders created automatically by like .vs. This is by Visual Studio. We can do .vs code as well. We don't want that folder either if that was created. So now, if we do git status here, you'll see that it's no longer listing the obj file, but it is listing the git ignore file. It's a very good practice to actually commit the git ignore file. There is one more important file that you can create like this. It's called Git Attributes. And the Git Attributes one, it's slightly more. It's not as straightforward as the Git Ignore one, but it's still extremely useful because what you can put in here is things that will affect anyone. Like it will tell Git some things about your repository. For example, you can override what way it what diff modes it uses for different files. Like if you have markdown files or maybe some sound files that are you can specify that, hey, these are binary, don't try to diff them. But the most important one is put a star and then some kind of white space, and you say text equals auto. This is a pretty important one. This basically means that if you do editing on a Windows computer or on a Mac or on a Linux computer, it doesn't matter. The line endings will be normalized. To me, this is sort of important. So let's keep that in there. That's just really nice to have. Right. So now, once again, if we git status, we'll see 4 untracked files. So now we can first I'll just add one like directly. We'll do add program.cs like this. Boom. So now if we do git status, you'll see that, hey, it says there's a new file, program.cs. It's now, this file is called staged. This file has reached a state called staged. It means that it's been prepared for adding into our repository. The other files are not staged, meaning if I were to commit now, if I were to type git commit, it would only commit program.cs. So what we're going to do, actually, we're going to use the command it listed up there. We're going to do git rm cached program.cs. This will remove the stage, like we have unstaged program.cs now. We're back to what we were before. In fact, I'm only going to add the .git ignore, and I'm going to do Git Attributes. I'm going to add only those. And then I'm going to commit. Now, I could type git commit like this, and I think it's going to throw me an error if I do. No, actually, it opens up a text editor. And this is where I'm supposed to add my message. And you have to have a message, and a message is 2 parts. The first part is a short summary. So I'm going to say something like added. Oh, let me say, yeah, added git baseline setting files. Yeah. Right. And then so I was using Vim there, by the way, but you can, any text editor is fine. And as soon as I quit that editor, it will take that file and use that. So now if we do git status, right, it'll say on branch master, it no longer says there's no commits. In fact, if we type git log, we will get a list of things. We'll see, oh, look, here's a commit with some long random name. These are randomly generated, and you rarely need to use all of them. If you need to target something, you can just use the first 6 or so. But it says, hey, I wrote this, and this is the summary. Okay, cool. What if we then git add dots? So now this will add all the other files. So now we've added program and hour of code, the CS project file. So, however, what if I realize that, I didn't want to say hello world. I want to say hello hour. I should zoom this in as well. Hour of code users. That's what I wanted to say. I didn't want to say hello world. That's a boring message. Now, what happens if we do git status? Well, once again, you're going to see that, hey, we did stage it. Program.cs has been staged, but it has also been modified. Right? It's compared to the staged version. This is different. So if I were to commit now, I would commit the staged version, not the actual version on my hard drive. So I need to git add either dot or program.cs to update my staging. Right? So now we have the latest version in my staging as well. Right, so let's commit that, but this time I'm going to use the M flag. So the M flag is really nice because it doesn't open up a text editor. Like, not everyone is fluent in Vim, and I understand that because Vim can be really confusing, especially for beginners. And like a terminal text editor is not really something you see a lot on Windows. So we can do git commit -m and then just type the text in here. So we'll say add git stuff cs proj and baseline No, well, that baseline we've already. Add project stuff. Add initial project files for .NET. Great. So now we've added those two. So now they are committed. So now if we were to do git log, we'll see there are two different commits. We have the oldest one, where we just added the baseline git settings, and then we have this one. Now, this is basically the most important things. Like this is the most important things. We can commit things, and what this gives us is that we can go back in time. We can check out one particular one of these. However, I'm sort of a bit of an impurist, and like I don't use the Git terminal a lot myself. Sometimes you need to, because this is the actual Git. When people talk about Git, they usually mean the Git terminal. However, there are a bunch of really good Git clients which give you a graphical overview, and the terminal purists say that you shouldn't use the Git clients. You can configure your command line client to be exactly what you want it to be, and that's all true. You can, but it's a lot of effort, and honestly, I'm not a guy that likes a lot of effort. So I'm going to show you Fork. Fork is my favorite client, and we can open a repository here. So I'm going to go here and in here and click select folder, and look, it's the same thing as we see in here, but it's in a visual way. So I can see that master is currently here. This is the previous commits in master, and here's my list of branches and stuff. So we can put fork down here and use that to kind of see what's going on, right? It's quite nice to have a visual way of looking at things, and we can see what has changed here, by the way. And this is all available in normal Git as well. So in order to show this, we'll actually make some changes so that we can get a diff, right? Because currently we've only committed new files that were untracked before. So we're going to edit one of those files. I guess we do some stuff like here. So we'll add a little bit of for loop where we say, sorry, I bought a new keyboard today because my old one stopped working. Thank you for joining us. Just some code. So now, once again, if we do git status, we'll see that it's modified. If we do git diff, it will tell us what has changed. And as you can see, look, it's like, hey, this line is new. These lines are new. Okay. Reading these diffs can be pretty confusing for beginners, but it's pretty handy skill to have. And if we look at fork, yeah.
If you committed program.cs,
yeah,
then you go and modify something, and maybe forget that you modified it and commit. Does it give you a warning that you have modified the file that's being committed, or will it just do it?
Right. You mean, so if I were to type git commit now, you mean?
Exactly. Yeah.
If I do git commit now, it will probably tell me that there's nothing staged. Yeah, look, git commit.
Yeah, so
there's nothing staged. Yeah. Hey, there are unstaged changes, but it won't. If you had something staged, it would not warn you that there are unstaged. Right. You should get into the habit of typing git status. There are a bunch of scripts you can get. For any, I'm using PowerShell right now, as you can see here, but there is something for PowerShell. There's something for even the default command line. I know maybe not the default CMD, but for Bash, for Z shell, for Fish, any of the popular Linux and Unix shells, they have scripts that you can install that will tell you. So when you are in a Git repository, your prompt will change here, and it will sort of show what branch you're on, if you have unstaged changes or not, and stuff like that. Useful if you use the terminal a lot. I kind of like fork, so I have this thing here where it says, hey, you have unstaged changes.
Yeah.
So if I were to, I can stage to here. That's just like doing git add, and then I can commit from here as well. I can type, Actually, I'm going to unstage it so I can show you another command. We can do git commit am or a-m. It's literally the same thing. You just do am, and that means add and message. So the A stands for add. It will add any unstaged changes. before it commits, and M will be, so this is the beginner's go-to command. It does everything you need, right? So we're just going to type add a thank you for loop, add you a thank you loop to our program. And there we go. One file has changed, 5 insertions. That's these 5 lines it's talking about there. So if we do git status, it shows. And if we go fork has updated, and it will tell us that, hey, master is now here. So now let me show you a branch. Let me show you what the purpose is of a branch. So I can do git checkout -b, and I can give it a branch name down in here. This is the old way of doing things. Actually, when I was researching this topic, I asked for suggestions on Git commands that I definitely should cover, and someone actually suggested a command I had never heard of before: Git Switch. So Git Switch is a pretty new command. It's only existed for about a year, and it's an easy mode version of checkout, because checkout can do loads of crazy things depending on what flags you put here. So -b, for example, means create a new branch and check that branch out. And you can give it a name. So I'm going to call it feature slash A, right? We're going to make, this is feature A. Just to show you what that looks like, we can see that we now have 2 tags here. These are the 2 branch tags. We have feature A and master. They are pointing to the same commit. That's because when you create a branch, it by default starts where you are at. So I was in master, so it starts at master. These 2 are now pointing to the same place because I haven't committed anything. But any commit I will do from now on will by default go into the branch I'm checked out in. So if I do git status, right, it will say on branch feature /A. So if we were to make some changes now, right, we maybe say like, well, we're going to add a new file, right? We're going to add a new class. We're going to call it class A. And yeah, we have a property in here maybe that's like number of A users. Really useful. Yep, this is great stuff. We'll create one of those. So you say var and then we'll do a dot, number of users plus equals 1. Great. Perfect. Right, this is exactly what we wanted to do. Really complicated code, right? No, not really. But if we then do git status, once again, status, we'll see that we have modified program and we've added a new file. Okay, cool. So git commit am, added class, added the a type user tracker. Now if we look here in fork, we can see that master is still down here and feature A is up here. So feature is ahead of master. That is true, right? It has one. It knows that feature A came out of this one. This is the parent for feature A. So master is ahead, and because master hasn't updated, it says that's like why it's one continuous line. So now what we can do, right? We can do git switch master. Now we switched back to master, right? So this is symbolized by this little check mark here and that being bold. So we've gone back to master. So now if we open a Visual Studio, you'll see that my file is still here. Shouldn't be. Oh, did we? Now we can actually check here. What did we do here? Oh, look, we didn't. We actually have we didn't commit these changes to class A. We never committed them. Oh, well, let's fix that before we continue then. So we're gonna git switch feature A. We're gonna go back here. We're gonna I think the problem with git commit-a is that it doesn't add new files. It only adds your current modified files. See, this is things I keep forgetting. One, because I don't use the terminal one a lot. I use fork so I can see it visually. It's just easier for me. But we can, we'll just do add git add dot. So git status should now show it. Yeah, there we go. So git commit. And now I will show you another command. I will show you amending. So we can do amend. This will basically take your current stage changes and add them to your latest commit. Because I forgot to commit. This file was supposed to be part of the last commit, right? It was just me being silly. I forgot it, right? So we'll just do this, and it will make me verify the message. But yeah, the message is fine, so we'll just exit. And then if we do git status, we'll see that nothing here. There's no unstate changes. If we go look at all commits, it's the same commit as before. It even has the same ID. However, it now also contains class A. So amending will by default, it will update this commit, and it's really useful for it's designed for, oh shit, I forgot to stage this file. That's the case it's supposed to do. That's what you're supposed to use it for. Don't use amend for other things. You can also use amend to, if you you commit something but you don't push it, and then the other day you're like, wait a minute, that message is terrible. I wrote fixed issues or fixed bug. Well, that's not a good message. I should write a better Git message. Then you can use amend to change the summary, because it lets you update the commit, so to speak. And if you haven't pushed your commit yet, that's fine. And we'll go through what pushing is soon. I know that's the first time I bring that up, so we'll go through what that is soonish. Basically, it has to do when you're working with a remote. But what I wanted to do now is I wanted to go switch back to master and create a new branch. So previously we used checkout -b and then branch to do that. You can also use switch for it. You can do switch and then you type /c and then the feature name. That will create a new branch. So that's just the $C is for create. So we switched to a new branch feature /b. If we go here, check what that looks like, we'll see that b is equal to master. Makes sense because we moved to master before we created it. Otherwise, if we had created it while we had feature A checked out, checked out, by the way, means the current branch you're working on. So if we then go in here, right, and we make some changes, we're var b equals, oh, we're not inside the method. That makes sense. So var b equals new class B, and then we'll do create a new file, and then we'll do b dot name equals Chris K, because he is always the name of anything that has anything to do with name, and we'll just generate a property for him as well. Cool, perfect. This is exactly the code we wanted to write. So we do git status, yeah, we do git add dot, we do git commit, add the Chris tracker. Really important stuff down here. So now if we look in the visual, we'll start seeing some branching. Look, yay! We can see that B is here and A is here. Which one is continuing the main line doesn't really matter. We can see that there is branching. So now, because let's imagine that these are much more complicated features. Now, maybe I want to, I've written all this code and I'm like, you know what? This feature is ready to go back. This was an experimental feature, right? It's its own feature. I'm working on a new thing. When this new thing is done, I want to bring that back into master, because I want master to represent, my latest state of confirmed, only done code is in here. Code that's being worked on is in feature branches, like A and B. But I want this to go back into master. The way you do that, we're going to start by merging B. We're going to merge B first, I think. We're going to do, first we're going to switch branch. We're going to switch branch to master. So we're going to do Git Switch Master, which brings us back into master. And then we'll do Git Merge, and then the name of the branch you want to merge. So we'll merge B. git merge feature B. If we now look here, we'll see that once again, master and feature B are at the same place. And at this point, we should probably remove feature B. It doesn't do that automatically. I think there is a switch for it, but once again, I don't use the terminal very much, so I don't remember what it is. But yeah, let's throw away B, right? We don't need B anymore. We're done with B. So we're gonna delete feature B. Click, done. Because we've added that back into master. As now you can see, there's no reference to feature B anywhere. It's gone, and that's because all the commits that were made under feature B they now live in master, right? They have been merged. The chain has been merged. So now, but feature A is still here. And in fact, maybe feature A is not done yet. Maybe we need to add some more things to A, right? Let's actually do that. So we'll do git switch feature /A. And we're like, oh yeah, this one. But we also forgot to say a.author equals Pobiega. We needed this as well. We forgot about this property. So we'll create that. Yeah, cool. Yeah. So git status, git commit am, added author property to the a type user tracker. Good stuff. Now, if we go git status, sorry. Yeah, we'll see that. Yep, feature A has been updated again. Great, we're now here. Okay, now we should merge this too. Now I'm going to show you a new thing though. It's this one, merge squash. Because this one is really interesting. It's because we've now made two commits. We added the A-type user tracker and added an author property. But in reality, these commits make sense to be individual because, like, they were done individually over time. But when we merge them to master, we sort of don't want them to be individual anymore. We want them to represent one change. Because that's what a commit is. A commit is a snapshot of time, sort of. But they're supposed to, like, you don't want a commit in master, definitely, maybe not like in feature branches or experimental branches, but in master or other like long-running branches, you want the commit to be a known point of code, a known point of time, and a meaningful point of time. Because what you can do with commits is you can revert them. You can undo the changes that were made in a commit. It wouldn't make sense for me to undo this, like only this, for example, but keep this. It would make no sense. So these two, I want them to become one. I want them to become one commit. And that's what squash means. Squash will take any commits in a branch and squash them into one commit. So if we git switch master, we can then do git merge squash feature /A. But we can't. It's saying there was a conflict. It's saying there was a conflict. And of course there was a conflict. Because we have both the B and the A modified program. And Git couldn't figure out which one goes first, because they modified the exact same lines. So we will have to change it for it. And Git by default puts in these weird tags like this. They let us know that we're in a merge conflict state. You can just fix your code here and then commit, and it will be fine. But once again, I like using fork. So fork can tell me there's a conflict. I can click resolve up here. I can get to C. Squashed commit to the following. Okay, interesting. I want to merge these. Yeah. It tells me the changes here. I'm going to be like, yeah, well, I want this, but I also want this. It suggests I put them like this. You know what? I want another line break there. Resolve. Now the commit is now the resolving. I've resolved the conflict. So now I can click squash, which would have been the exact same thing as just doing the command again. So now if we do Git Status, we'll see our working tree is clean. There are no unstaged changes. If we go here, we'll see that squashed commit of the following. Right, so I probably should have changed this description. My bad, I kind of forgot to do that. And if we now remove feature A, right? Feature A has been merged, right? Remember, our current state is the latest state of everything, right? We have both A and B in here. So if we remove feature A, boop, it says it's not fully merged into head, but it actually is. It's because we squashed it. We broke the history a little bit, but that's okay with us. Now look, this is pretty clean, right? We've cleaned it up. So it will actually say squash commit of the following, and it just added the reference to these two commits. So these two commits no longer exist. They have been removed, and a new one has been created in place that represents both of them. And this is pretty common to do when you're working with other people, is that when you merge a feature branch, you squash it first, so that your entire feature can be considered to be one commit. And that's because it might need to be reverted in the future. What else do we have to talk about today, right? We've done Git Init, we've done Git Add, we've done these two, we've done Status. We haven't done these guys, right? We should do that. We've done the others. Yeah, so let's go talk about that. So what is Git Remote? So Git Remote is it's a command. Actually, it didn't do anything because I don't have any remotes. So it would have shown me what remotes I have, but I don't have any remotes. So a remote means it's a short for remote repository, and it's basically the same. It's like a link to another repository that represents the same project. 99% of the time, this is going to be GitHub or something similar. So in fact, it's so common that it is GitHub that I'm going to show you how to set up a Git repository, a GitHub repository. So I'm going to drag over my Firefox window here. And this is just github.com logged in as me. So the first thing we're going to do, we're going to click new here. New repository, create a new repository. Yep. I want this to be a private repository because I'm going to probably delete this afterwards, but we'll call it Hour of Code Git Stuff. Terrible name, but we'll go with that. Description, my sample repository for Hour of Code. We don't want to click any of these files right now. We can do that later. We can add readmes and Git ignores and stuff later, right? Because we already have a repository. This is great if if you can create this as your first thing and then add your files later. I don't like doing that because Visual Studio likes creating your projects for you, but it's it's something you can do. So we'll just go create repository. Great. Now look what we got here. We got these things. Quick setup if you've done this kind of thing before. It also tells you like, hey, here's what you can do. Look, it literally tells you can run this command. There are two modes of using GitHub. There's HTTPS, which is the easier way, but the worse way. And then there's SSH, which is the better and safer and more convenient way. I highly suggest you use SSH if you can. It requires that you have an SSH key and that you've added your key to your account. I'm obviously not going to show you my key because that would ruin it, but I have. But yeah, you can use this one. The only difference is that if you use this one, it will ask for your password every now and then when you try to commit or pull. And if you use this one, you're actually authenticating with a key instead, so you don't need. So I'll just copy this. And actually, you know what? I'm gonna copy this, right? I'm gonna copy this. I can show you the command. So push an existing repository from the command line. That's exactly what we want to do. This is exactly what we want to do. So we go to our command line. We paste the code. So git remote add. This is an identifier. It is considered good practice to call your single source of truth repository or whatever, which is your usually your GitHub or GitLab or whatever. You call it origin. Another common name is upstream, and that's if you have forked. Like if you have made a copy of someone else's repository, then you will have both of those as remotes. You will have yours as origin, and you will have theirs as upstream. This will let you pull changes from upstream into your branch, so into your fork. That's how you update your fork. Very, very useful. So now if you type git remote, we should see origin. Yeah, we have an origin. Great. And if we do git status, it should tell us that, no, we haven't set up any tracking. My bad. Master doesn't know, like, so each branch can be linked to another branch. And I think that's easier to show here. So currently, here we have origin. We can read through this, right? They just git branch. This sets up tracking, I think, and then this pushes. So, and like I said, by default, it will call its branch main. But we don't want to call it main. We want to call it master, right? That's what we call it. So we'll just do. If we just push now, I think that should work. So we just do git push u. That the dash u is for tracking. That's right. Origin. So this is the remote we want to push to. And then we type master. So push. The command push pushes your current state, your current branch, to a remote. That's all it does. And you get this fun prompt that says, hey, this is what happened. So branch master set up to track remote branch master from origin. Okay. If I refresh here, we have a branch called master and we see our code in here. Perfect, right? Cool. Awesome. That was easy. So now I have this repository. Awesome. And I could, if this wasn't private, if I'd set it to public, I could share this link to people and they could come here and check out my code and do stuff. And that's where the other commands come in. So I think we'll have to simulate a multi-user setup somehow. Because what I wanted to show now is fetch and pull, which are basically the reverse of push. Push pushes your changes to a remote. Fetch will ask the remotes if they have any changes that you don't have, and pull will actually get those changes and forcibly drag them down into your repository. That's like how you get up to speed. Git does not do any of these automatically, and that's because Git is supposed to work just fine if you're offline. You don't. Yeah. Git is an on command type terminal application, right? It doesn't do things automatically for you. It does things when you ask it to do things. That's part of the Git philosophy. Some of the clients do things differently. Like fork will actually fetch every minute, I think it is. It will do a little fetch here, do a little fetch there to check for changes. We can do a fetch here. It won't find anything because there are no changes. We are the only ones pushing here. But we could emulate, let's emulate being a different user, right? We can click here and we can get this again. And we will open up a new one. In fact, you know what? I'll open up an Ubuntu one just so we can keep them slightly different. So we'll go ls. Oh, Jesus, it's in, yeah, let's just do cd. ls here. We will do git clone, and we'll paste this in here. So clone is the command. Oh, I couldn't read. That's a private repo. Of course it is. Sorry. So let's not use the Ubuntu one. I haven't set up my key on my WSL account. Let's just go to a different folder and check it out there. So we'll go to E again because that's where I keep my stuff. We'll do mkdir temp, cd temp, and here I'll do git clone the URL. So clone is the command line command to download a repository, and it will by default create a new folder of that name. So if we do if we just do ls here, we'll see that it created a folder called hour of code git stuff. So we'll go into this folder here. Now, if I want to appear as a different user, I need to set a setting for that. I'm just gonna quickly Google what that is. It's like Git Config User. Yeah. So we do Git config. We're not going to do global user.name, first name, last name, and we need to set email as well. So email is important. Okay, cool. So we'll do Git config user.name some other user, and Git config user.email. Yeah, we'll just type in random at Gmail. No, random at test.test. I don't think it needs to be a real one. So there we go. Now, if we can make changes in here, they will be from that user. But when I commit, I will still use my SSH key, so it will be allowed, but it will appear to be from another user. So now what we need to do is we need to make changes to this one. So we'll do code dot here to open up this one. Yes, I trust the authors. That's a new one still. Right, so we make a change here. Actually, before we make a change, we're going to do this the proper way, right? We're going to make a pull request. We're going to make a feature. So we're going to git switch C, create new branch. We'll create feature / changes. Really bad name, perfect. And then I say, thank you for joining us. I hope you learn a lot. And maybe 10 times is too much. We're going to do this 5 times. That's a much better amount of things to do. So we'll do Git Status. We'll see some changes. We'll do Git Commit -am to add and give a message. So I'll say like update, reduce console spam when greeting new users. Now we can push. We don't have an upstream. We don't have a remote here, I think. Or do we? Git remote. No, there's a... Okay, cool. So we'll just do git push. Git push u origin. Feature changes. Right, that worked. So now, if I open up fork here, just so I can actually, let's not use fork, right? Let's do it the classic way. So we'll go back to the main one, and we do git fetch. So this will check, hey, it says, hey, I found some new things. I haven't pulled them into your repository. Your state is still untouched. And remember, this is here we can say, some other user has made some changes here. Okay, cool. So I can pull, we won't do anything because master has not been updated, so pull won't do anything. But I could check out this branch, right? I could check out this branch, and it would create a copy of this branch stuff because, well, like you can only have things that exist locally. But more likely, what we actually want to do is we want to simulate this person wanting to make those changes. So we can do compare and pull request. So pull request is not a feature in Git itself. It's a feature on GitHub and GitLab and Bitbucket. So it's not made by Git. It's just and it's a lot of people are confused by why the wording pull request. Why isn't it called push request? Well, because normally what a pull request means is like, I have a branch. I suggest that you pull this from my repository to yours. That's what it usually is. It's just we use the same term to refer to like in repository, like working within the same origin. So I'm saying here, like, I want to pull this into master. That's what I want to do. So I want to reduce console spam on greeting users because right. So we create a pull request. Now, this is a bit weird, right? It's because I am the only person in this repository and I created this pull request. Normally the person who made the code would, like, which is some other user, right? He would have clicked here, but that person does not exist and uses my GitHub account, so that won't work. And here we can say we can create a merge commit, or we can squash and merge, and we can rebase and merge. Rebasing, I'm not really going to cover that today. It's a pretty complicated topic, but it basically means changing what commit is the parent commit of your commits. It's weird, but it's really useful sometimes. But 99% of the times you're fine with the other two. And since it's only one change, we can do. We're gonna do we can do merge commit, so we can show that at 2. So we're gonna just click merge here. Yeah, because like, you know what? I think this is great. As a repository owner, I said this is a great PR. I want to merge this. Now what will have happened is that this will actually have been merged. So if we go check here and we fetch again, we'll see that, hey, master has been updated. I have merged a pull request. So origin master has been updated. So now, if we go back here and we do git pull, our master will be fast forwarded. It just means that there were no conflicts, right? Their master was just ahead of our master, so we pull those changes into ours, and that looks like this. We just moved up here. That branch still exists. I can delete that branch. So now, if we then fetch again to fetch that change, we'll see that the branch is gone. But that commit still exists, obviously. That commit still exists, right? We didn't squash it, so we didn't delete the commit. Merge is the merging strategy. Like, just doing a merge commit is the merge strategy that is the friendliest to your history. However, sometimes you do want to rewrite your Git history. Git lets you do that, by the way. You can delete and change commits as much as you want. And if you are working on a private project, I suggest you do it a lot, because it just keeps things clean if you merge, squash and things. And but some companies or some people don't want that at all. They prefer, keep the history trackable. So let's see what we've talked about now. Now that was fetch, push, and pull. Cool. And remote. So we've done all that. We have talked about Git with and without GitHub. I mean, first I showed you how to use it just alone. Like, this is just Git without the remote, and then you had Git with a remote, which was GitHub. We showed how to make a repo. We showed the pull request flow with branching, committing, pull requests, reviews. I didn't show you reviews, really. But we can go through that as well. I showed you merge strategy and I showed you close PR. Well, we'll go over a review shortly. But I want to talk about Git Stash, because what's really common is we need 2 branches for this. So we'll have to make a new branch. I can just click here, feature some feature, and I'll automatically check that out. And I want to make some changes on here. So I'll just say, yeah, this is great. Yada, yada, yada. This is terrible. Remove this. Just some change. I'll just go in here. I'll type add a stupid comment. I'll let the stage before I can commit. I commit. If I push this, it will show up on GitHub, right? I'm not going to do that right now. But what I want to do now is I want to make some changes more. I want to make some more changes. I want to say, like, some other change. Lots of changes here. I want to change this to Pobiega plus a number of users. I don't know why I did this, but I want this. But I don't want to commit this. This is just something I have, right? I just have all of these changes. Now, I'm working on something. These are changes, part of my new feature, but I'm not ready to commit yet, because I don't want to commit. Like, for example, it's considered really bad practice to commit code that does not compile. You want your code to compile and preferably run. Maybe not run, but definitely compile. You don't want to push uncompiling code. Because, like I said, a commit should sort of be one useful state that you might want to revert to later. During development, that is less true, but still, you don't want to push like random stuff unless you have to. Like, I mean, for example, if you're on a computer that you're going to lose access to, or you're worried about your hard drive failing, it might be worth pushing uncommitted, unworking stuff as well. It's up to you. But in a professional environment, we usually say, only commit if it's a working state. So that means you sometimes work with unstaged stuff, but then you get a bug report saying there's a bug in master. We need to release a hotfix. We need to fix that bug, but you have your changes, right? So in this case, I think it's just going to work fine if I change. Yeah, I can probably just check out here. No, I can't. See, it said, hey, your local changes. We can't go to master. You have local changes that are not compliant. We can't do this. Well, then I can stash. I can just, okay, I'll just click stash up here. It's the same as doing git stash here. Stash. And if you just do that, right, it says saved working directory and index state working progress on some feature. That basically means that it takes your local changes, the unstaged stuff, and removes them. But it doesn't actually just remove them. It puts them somewhere. It puts them in a stash, which is like a little bit of a code vault. So we have those changes here. Now I can move to master and make the changes and then go back to some feature. And then I can say, pop my stash. You can apply the stash. And that will, redo these changes to your local files. I don't, off the top of my head, remember. Is it stash pop? Git stash pop? Yeah, okay, so git stash pop and git stash apply. So if we then want to make those changes again, let's say that I just want to make sure I'm on the right branch. Yeah, I'm on some feature. So we do git stash pop. And now suddenly, if I git diff, you'll see all those changes again, right? I've just applied those changes. Pop, and then my stash is now gone. That's what pop does. Pop deletes the stash after it has been applied successfully. If there were suddenly now changes where, like, if there would be a conflict here, it would have gone into a conflict state, and it would have kept the stash for you, so that it's safe. But that is a very, very powerful command because it lets you, like I said, I have these local changes, but I need to go edit master right now because of reasons, and you can do that. So to end things, let's show you a review. And to do that, I'm going to go to my main page here. And actually, no, I'm going to go to my main page like this. And we're going to go check out a current pull request that's active in the BusyList project. So here, Alex4040, or Alex Baraza, has made some changes. Right, so he made 18 days ago, he created this, and he made some stuff, and I had some comments, and then he made some more changes, and I requested some more changes. Like, so this is like this is a review, right? So I can see here. Oh, look, he did this, and then I said priority is not optional here. I said, okay, I think this should be optional. We shouldn't force the user to prioritize a command. Same thing here. I say, well, this certainly works. See if you can't use this brush return command to clean this up. If you need help, reach out to me on Discord and we'll figure out. This is a review. This is the review, how the review process looks on GitHub. Is that you will view files like this. You can check them as viewed if you don't want to see them again. Like if you're halfway through, it's really useful. And you can like click here, and I can type something, and I can say, is this a single comment or is this part of a review? And then at the end, I can either approve, request changes, or just make a comment. And the trick, and once we've set this repository up to require 2 approvals. So right now, yesterday, I approved the latest version of the changes. In fact, he had, look, if we can actually see here that after Chris reviewed here, he actually approved. And it had 2 approvals. But Alex decided to make another change, so he dismissed the stale reviews. That basically, like, he threw them out. He said, I have made more changes. These reviews are no longer accurate. I looked at the new changes and I approved them without a comment because we had already talked about it here. And now we're just waiting one pending reviewer. We need one more review here before we can merge this. Now, I am an administrator. I could click squash and merge now, but that would break the sort of rule we have, right? I want this to be by the books, so I want one more reviewer. And then when that person approves, then either I or anyone with merge rights, which is basically, I think that's pretty much everyone in this repository, can click this button here. But normally that would be anyone who can write to the repository is able to merge. And that's basically it for Git. There's just one more thing I really wanted to comment on, and that is like something that people often ask me, and that is, how do you write a good commit message? These are not the worst, but they're not very good. You'll note that like I don't do the whole fix bug or add code, because what does that tell you, right? The summary is supposed to tell you. It's a summary of what this commit does. So it needs to, and the best example I ever heard was that write it so that it completes a sentence. We're going to go here. I'm going to zoom it, close this, and zoom in a little bit here. That was a lot. But write it so that it completes the sentence. So a commit message if accepted, this commit will ... And I actually broke against one of my own rules here. I was doing capital A's. Normally, because you're finishing the sentence, right, these should be lowercase. That's nitpicking, of course, like super nitpicking. But that's one of the things I think. So if accepted, this commit will add initial project files for .NET. Yeah, that makes sense. Sure, I mean, if accepted, this commit will fix bug. That sort of works grammatically, but like you're not being very informative. And that's just for the summary. But when we make a change, right? When we make a change, we have the subject, but we also have the description. So subject, this is the summary. So this would be like, add comments. And normally a commit is sort of supposed to be one thing. So for example, in this case, I've changed this and I've also added comments. So just saying add comments here would be bad, because it doesn't also tell you that I changed the author. Author calculation logic. I mean, that makes okay. So if accepted, this commit will add comments and update author calculation logic. Slightly better. It's still not good, but it's better. And then if I want it to be really good, like this is only something you would do at a company, and if the company mandates it, really honestly, is you would in much more detail describe what you're doing. So you would like. And here you don't need to. Here you're not completing a sentence. You can be as verbose as you want. This is only viewed if someone checks the details of your commit. So I could do something like, due to, I wanted to add some clarity to the confusing print statements in program.cs, so that next time we enter that file, it's a little more apparent what goes on, as this has been an issue over the last few months with several bad commits that broke the production build. I also updated the author naming logic after a long discussion with Chris, who agreed this was the best way forward. Right, this was incredibly verbose. I very rarely use this, but sometimes. So what this means now is, this is what people will read most of the time. But you can click. You can read the if you want more details on why these changes were made and they provided this. You can go here. Most of the time, this will be empty though. Like 90% of the time, this will be empty. Okay, that's just life. That's okay. Yeah, I think that's pretty much it, right? I think we actually managed to go through everything, and it took only slightly over an hour. So, are there any questions right now?
Not for me.
Yeah, it seems pretty clear. Thank you.
All right, cool. Thanks. Yeah. Thank you for coming, everyone. And I'll see you next week. But don't forget to nominate topics and vote so we know what we're going to talk about next week.